Hello, welcome to another video of this SVA Design YouTube channel. I'm Shaquille Veldboom, and in this video I wanted to kind of walk you through the gearbox that I designed, why I made certain choices, all of the above. Without further ado, let's get into the video. So the first thing you will see that the engine will be connected to for the gearbox will be, of course, the clutch. And this may look like a double clutch or whatever, but this is a single multi-plate clutch, and single multi are two opposite words, so that might sound strange, but it is a single clutch, so there is just one flywheel that is attached to one output shaft, so it is only one output shaft, so single clutch. But there are multiple plates, multiple friction plates between the actual flywheel and the actual output shaft, so the force is just divided between those multiple plates to have a similar surface area, because this is only, I believe, 18 centimeters big. This is a very small clutch, so to still have this surface area you need to provide enough pressure between output shaft and engine flywheel to still have like a single drive line. Instead of it slitting constantly, you will have to use a bunch of plates. So the way it works is there will be some sort of a pressure plate here. I haven't made that yet, and also need to figure out how I will operate that, and probably will be electronically, because I won't have like a clutch in the car or whatever, so that is something that I still need to work out. But beside that, the way it works is pretty simple actually. If we take like a section view like so, this will be bolted directly to the flywheel, directly to the crankshaft of the engine. So this will be spinning at a pretty high RPM, and also with a lot of horsepower connected to it, so a lot of force and a lot of torque and everything. This will be connected through the gearbox, and as you can see, the multiple gears, and also the differential, and eventually the wheel attached to the rope. And the way to transmit the force, the rotational force of the engine to the wheels, is through this clutch and through friction. And this friction is created by applying a lot of pressure on this plate, and this plate will again stick to this plate, and that will kind of run through the whole system. So once you disengage the clutch when you're standing still, you can just pull it back, and you will see that there won't be any contact between this friction plate and this one right here. And these will be made out of different materials, some sort of carbon or steel, or yeah, just different sort of fire retardant materials. And this will be at this point free to rotate, because it's not in contact with anything, so there won't be any friction created. So the flywheel will be able to rotate individually from the output shaft. And as soon as you engage the clutch, you want to drive off the power of the engine, and you will need that rotational power. You can engage the clutch, apply a lot of pressure to this plate right here, and this will press down onto the rest of them. And this version, like so. And with all of this pressure, this will kind of have to be moved as a single unit. Right now SolidWorks doesn't really know friction, so I will still be able to kind of rotate it. But in the real world, all of that pressure and all of that friction will make sure that it is moving as a single unit, and every single RPM from the engine will be directly translated into a single RPM from this output shaft right here. So that is basically the whole purpose of this clutch. And again, this will probably be a wet clutch, so there will be, this whole box will be just yeah, full of fluids and everything. And this whole output shaft are the 6 gears, and as you can see, there's a very small one right here, so that will be first gear, second gear, third, fourth, fifth, and of course sixth. And one thing that might surprise you is there won't be a reverse gear on this car, and the reason why I will explain later on. So as you can see right now, we have all of the gears lined up against the output shaft with the corresponding gears on that. So when I start to turn this, so let's say the engine is turning and clutch is engaged, but no gears are selected at this point. So you can see that they all have been lined up, and they're kind of moving, and even though this is not really how it should be, and it is rotating with the ratio, differentials and everything, so that it's going good, even though the teeth aren't lining up, and you can see that on multiple places. And I should really redo that just to make it look good, but for now the purpose is clearly shown. But if you can see what I'm doing right here, I can just turn this wheel, the 6th gear right here, and you can see that one single rotation from the 6th gear will cause the output gear, the smaller gear on the 6th gear, to rotate way more rotations. So this is what you call an overdrive gear. So one rotation from this gear might be even 2 rotations from this gear. I don't really remember the ratios that I used, but it's an overdrive. And the same goes for the 5th gear. So you can see that one rotation will translate into multiple rotations. I think it's 1.5 something. So 5th and 6th are both overdrive gears, and 4th is it's not the overdrive, but it's just a regular gear. But this one will reduce rotation, so one rotation from the output shaft will be like, let's say, 0.9 rotations on the input shaft. And same will go for 3rd gear, but then the ratio will be even larger, and that's basically how gear ratios work. So a single rotation from the output shaft will cause the wheel, no sorry, a single rotation from the input shaft because the output shaft to rotate more or less depending on what gear it is. A lower gear, it will rotate less, so that rotational energy will be transmitted into torque instead of horsepower, and on a higher RPM, on a higher gear, it will be the other way around. So the rotational energy will be transmitted instead of being torque, will be horsepower, so you can go and reach for top speed. So that is basically what a gearbox does, to give you the power when you need it, where you need it. So that is basically what these gears are doing. And if we take the next step, that will be the synchronizers. What the synchronizer is doing is pretty simple actually. There will be a dog gear. I don't know if that's the right word for this part, my bad. But there's this slider right here. So this slider, if I again make a section view out of this, make it a little bit easier to see. By the way, something I didn't mention, these gears are not rotating with the output shaft right here. They are detached from the output shaft, so they're just spinning on ball bearings. And this slider right here will be spinning with the output shaft, so this will always be in contact with the output shaft. So as soon as the slider comes in contact with a gear, so let's say 1st gear, the friction between these two will kind of cause this gear to spin at the same RPM as the output shaft, so that will trigger the wheels to start spinning. And that is not enough though to get it really locked in place, because there will be maybe some the pressure on it is not hard enough to kind of get it locked in place, so there otherwise will kind of tend to slip. So what we do is we add some a dog gear or something like that. I really don't remember what it's called. So what this slider above it is actually doing, so this here will, between this wall right here and this wall right here will be a spring, and as soon as you try to select 1st gear, that spring will the selective fork will be attached to this ring right here, and as soon as you push it, it will kind of push this one into this wall right here. So the friction that will be applied will kind of cause this gear to spin at the same speed as this output shaft, and that will allow this gear to slide right into place with these teeth that will kind of correspond with these teeth right here. So that is what you call synchro mesh. And as soon as everything is lined up, then and all of these are detached, as you can see, then this gear is selected and the output shaft will spin at the same speed as the 1st gear. And if you're trying to select 2nd gear, then this slider will, this gear selector will be slid back into place, and it will kind of push this one forward, and then this one will be able to select this gear because of the synchronizing time. And yeah, but I will put a link in the description for a video that kind of explains synchronizing a little bit better than I do. So that is for another thing. but those are the gear synchronizers. So as soon as all of that was run correctly, we are now up to the differential. So as soon as we kind of have everything done to, let's say, flywheels rotating, that rotation is being transmitted through this gearbox with these synchromesh gears and everything to the output shaft, and this output shaft is now starting to turn the differential. And the job of the differential is to have an option to let the driven wheels rotate at different speeds, because when you're in a turn, let's say this would be the car for instance, and this would be the inside tire, and this would be the outside tire, and this will be the point of rotation. So this is kind of the corner that it's making. As you can see, that outside tire is trying to make it has to travel a way larger distance than this inside tire is. So this outside tire would be spinning a lot more, will be turning a lot more circles than the inside tire would. So if the engine would be just attached to a gear that is just at a 90-degree angle and that would always spin at the same speed, then this tire will slip a lot because it has to turn way more circles than is actually needed if they would always spin at the same, always have the same amount of rotations. So this device allows you to create a mechanism that the tires kind of never spin too many circles, if that makes sense. So every single time this rotates, you can see already that this is will kind of be symbolized with the wheel. This will be attached to the actual tire. So you can see that this right now is standing still and this one is turning, and right now it's the other way around. But you can also see that when this one is turning, it's turning more circles than this outer wheel, because it's now this one is standing still. So if everything would be locked in place, they would be all spinning at the same speed. But this just allows you to have differences in rotation for each tire. And also another thing is, everything in nature, by the way, always chooses the path of least resistance. So if, let's say, this wheel would be on ice and it wouldn't deliver the system with any resistance whatsoever, and it would just allow the wheel to turn, then all the power would be directed to that wheel. So that wouldn't be beneficial at all, because all your horsepower would go to a place where you don't have traction. So that would just cause the tire to even spin more, and it will probably even result to you maybe even losing control of the car, so that won't be safe. So the way to kind of alter that is to have a locking differential, and a locking differential, this is an open differential, and a locking differential kind of helps the car to send power to both of the wheels in a situation where one wheel has more grip than the other wheel. And in this open differential situation, you kind of don't have that possibility, but the solution that I came up with for that is to have these two great big electric motors. So like I said, the power always chooses the path of least resistance. Well, extra power isn't just least resistance, it is extra power. So if I decide to put more horsepower on this electric motor than on this one, the engine power will also be redirected to that side. So therefore you can kind of choose torque vectoring, you can choose which wheel should have more grip at what time. You can, in a corner, have the outside wheel put more power down, and all of that. So that is kind of a problem solver. And the next thing that I also wanted to discuss is the motors that I actually used are these Yasa 750Rs, and a 750 stands for 750 Newton meters of torque that it has. Was it Newton meters or was it pound foot? I don't remember. I'll look it up. But the car will only probably weigh something around 700 kilos, and for a single 750 Newton meter electric horsepower electric motor to be there is kind of overkill. So what I was thinking is that it would be cool to have like real PlayStation style a button on your steering wheel when you for 5 seconds have boost, like real extra capabilities of accelerating when you feel like you have full grip. So that's kind of what I want this car to be. because you know I grew up in an era of video games and all of that, so I thought that would be a cool idea to have the possibility to just push on a button and have stupid power to just propel you along the road. Because with the motor attached to it, the V6 that I already built, I think it should be able to push like 400 horsepower just with that motor. That's a 2-liter V6 with a lot of other technologies attached to it, and then with these motors attached to it again, probably end up at somewhere around 800, but then when you push the button it will be more like 1500 when you need that extra power. So, and these are 37 kilograms a piece, so you'll have something like 7 kilograms of extra weight just by but you also need of course a battery, but just the motors. So that is the weight penalty, and you also need inverters, extra cooling, wiring, and all of that. So there will be a significant weight penalty, and also be easy to just take them off and not to use it. But I thought that would be a fun element to just have a button on your steering wheel and to just really accelerate harder and to really get a kick in your ass, just trying to accelerate harder and everything. So that was just something that was cool to me. So that is basically everything that I'm doing. So yeah, as you can see, this is what the unit will end up looking like. This will be attachment point for the suspension, and I also need to make more of them, so one right here and one right here, and I'll figure out how I do that with some rear frame mounts or whatever, or just maybe extend this. I think that will be the best way to go. But thanks for watching. That will be it for this video. I'm Shaquille Veldboom. This is SVA Design, and check out a bunch more videos from this car if you will. And yeah, that's it. Thanks for watching. I'm out. One thing I didn't mention, like I said, there is no reverse gear on the car. So the only way to reverse gear, to go into reverse with this car, is to do it actually with the electric motors. But you save weight. You don't have to use another. I don't have to have like another synchro mesh gear, dog gear selector. So it's also less complex and all of that. So if I decide to make a version of the car without the electric motors assist, I do need to go back into the gearbox and add a reverse gear. So that is something that will be a later process, but yeah, good that I'm thinking about it right now.